I think we're all set. All right, I'm Bill Holland from Facebook. Eran from Mellanox will be presenting with me. I'll do a couple charts and he'll cover the technical details. We're talking about Devlink, which specifically in this implementation is helping an Ethernet adapter with health capabilities. That's our primary interest in it, as well as other. In Facebook, and if you've ever had to debug a networking problem, a NIC on a server, you've probably run into the same things we run at. But at our scale, every single time we have to go look at a specific machine and figure out what's going on with it, that's a big stop to our daily progress. So it gets even worse when we have to consider that for each adapter, we might have a different utility to gather data. We might have a different set of data that's being gathered. We might have to go back and do problem reproduction. We might end up spending hours or even a day or two just getting enough data to report a bug to get started on doing diagnostics. Some of that's because different information is required based on what driver and what network technology. Also, different vendors have things that they want to look at that might be unique to their adapter. And then the worst possible scenario is we have to actually repro the bug in a live environment, which generally speaking, we're pretty quick to isolate a machine when it misbehaves, try and keep it from affecting the rest of production. So that's obviously a pretty big negative. And then lastly, and this is in the realm of extended capabilities that Devlink will allow, is the notion of actually recovering from an event that can be built into a software package is something pretty novel and different. There's a couple specific things we're trying to accomplish. The main thing is, if you think about debug time as sort of an end-to-end process from when you know something's wrong to when you've got a fix ready for it, we're trying to shrink that time so machines aren't out of production, issues aren't lingering. Having something that's in a real-time analysis mode so that it's noting when the machine's behaving correctly or not on an ongoing basis is obviously pretty powerful because you can get an earlier alert, you can get better information with that alert. Knowing that it's going to perhaps do some recovery, there might be maybe 50 to 70% of scenarios which it'll automatically recover. That greatly reduces the workload in the manual debug environments. And then for those cases where I do have to go in and do some debug, having that data, the important snapshot, particularly with firmware-rich adapters, there's an awful lot of data there that's very, very specific to that adapter, but having a common format for pulling it out and getting that data logged right at the time of the incident is tremendously powerful for us. And the main thing we're trying to avoid is having a whole bunch of different tools, particularly closed source tools where we have to take a binary blob and just trust it, put it in our production environment. We generally don't do that. So what we end up with is either trying to get open source tools or getting common tools such as what Devlink will provide. So it's a single tool giving us a lot of capabilities across platforms. And then the fact that we're not having to have different tools every time means that we're not spending time getting the wrong tools on machines or having to clean them up afterwards to move them off. So.
Okay. Can you hear me? Okay, good. So actually when Facebook approached us and wanted us to have something which will be in open source and will be standard, then we had to look on the kernel and then we understood that nobody did it before. So the first challenge here was to prepare some mid-core kernel core layer which will allow every vendor to come with his own set of functionality, or we called it reporters. You can see it in the middle layer. And by preparing this core layer, then we will have like some kind of standard behavior for all kind of errors and all kind of dumps between the different vendors. So if you like, everyone that is registered to the PCI driver layer can use this functionality. We are providing some real-time error alerting and error detection actually. Those reporters that I just mentioned are configurable. You can control it from the driver. You can also control it from the administrator level. We have many kinds of options, like if you want to recover from an error or not, if you want to fetch dumps, even if you want to like disable, like give a grace period that if you have 2 consecutive errors, you won't find yourself in a loop of recovers or in a loop of dumps. You can prepare your own error recovery method, which will allow, which will allow the driver to think in advance. If I stumble an error, how will I fix it? And then you don't need the administrator to start and thinking, okay, do I need to reset the driver or not? Do I need to change some kind of parameter because I have a very specific error? All of that is now in the ownership of the driver and the driver developers. We provide real-time diagnostic and status, meaning that whenever you want, you can just like set a command and get back what is the state of every reporter that you have on the system. You can understand when was the last error, how many errors were, how many recoveries were taken, and by that you can send the reports to the vendor for them to provide you a better hardware, firmware, or driver. The biggest thing here is that if you have an error on your system, till now we will need the administrator to take a look on the machine, read the kernel dumps and the kernel logs actually, and start preparing data to be sent to Mellanox or to any NIC vendor. And my biggest challenge as a Linux driver developer that most likely I will not get the full picture that I want. I won't get all logs, and every time I will ask for more questions and for more details. And this is, in order to fix that, we have prepared a set of dumps that we want to take per specific error, meaning that from advance I will know what I want the system to dump when I have a specific error. This will, as Bill said, will help taking all the dumps online, and then I won't need to take the machine out of the cluster for a debug, or even I won't have to ask for a repro because I already have all the details when the repro happened. As I said, we provide statistics. In addition, we have some special buffers in the kernel on which we log everything that Devlink Health has found or has reported on. Then you can come later and look for special things if you want to. And the good thing here is, starting from kernel 5.1, which was released almost a year ago, you can find all of it. Meaning that as a vendor developer of some NIC, you can just write your own methods and use this core layer. So what is our error handling flow? At first we are doing some tracing. We trace to a specific buffer for the administrator to know. We incrementing the counters. Then we are doing some sort of state filter, meaning that if we are already in error state and another error happened, it means that I'm not sure that I can do recover, and then I maybe stop there. But if not, I can take some dumps of the machine, save them aside in some special buffers on the kernel, which will be later taken by the administrator, and then I can set a recover flow. And this is the core handling flow, meaning that all reporters in the system will go over the same flow, and we don't need every reporter to reinvent the wheel in that term. Okay, so unfortunately, so far it's almost a year in the kernel. Only Mellanox have taken live action here and wrote the reporter. So currently we have 3 types of reporter, which reports 8 or 9 different errors. For each error we are doing live dumps, live error detection, and live recovery flow, meaning that if you have Mellanox NIC and you hit a TX timeout, we will automatically recover from it. And I think that the biggest thing is that if we have some firmware errors, that usually firmware errors are very hard to understand and moreover very hard to fix, we have all the dumps of the firmware already taken and waiting for the administrator just to fetch and send them for analysis. There is a very nice user command that can be used for Devlink. We have Devlink elf show, diagnose, dump show, dump clear, recover, and set. If one wants to use those reporter, you just need to use the latest IP route 2, and then you can build your own script on top. The beauty of it, it's also got into all new inbox distros like Red Hat, Ubuntu, and everything. So you don't need to do something special for it to reach your clients. This is some example we did in Mellanox in few months ago. We took a live cluster. We had about 15 machines, and we started running some traffic, and we deliberately hit some errors. You can see that we have machines that are marked as green, meaning that in the last 24 hours, nothing happens. So from administrator point of view, everything looks good, and this machine is healthy. The orange one marks that we had some error in the last 24 hours, but it was fixed. So it means that please take it into attention that you had an error that later you can ask for your vendor to fix. But for now, you don't need to worry because this machine is fine. And the last two machines we've read, meaning that they have like live error, which was not recovered or not recovered well. Because the administrator can say, I don't want to auto-recover, and then it means that the machine will be in a bad state until you will ask to fix, but it doesn't matter for this demo that we did. And then if we clicked on one of the machines, we could have seen that we have two errors. I mean, there are several different NICs here. Every NIC has few different reporters, and you can see the status per reporter, and then you can get a real picture of what is going on in your on this server. So one of the main reasons I'm here is because I wrote the infrastructure of the kernel. We put there about 7 or 8 nice features, and then we moved to have a lot of reporters. But all of it is open source. Everyone can see it. Everyone can contribute to it. It's in kernel.org in the networking subsystem. We have very good wiki page. I also attached the commits themselves. I already presented it in a different conference, and there is some nice paper I wrote about it. So if someone wants to understand what is the core infrastructure and take it into his own driver, then he is more than welcome. We are waiting for other companies that does networking drivers to start using this infrastructure and to add some more. Hopefully it will become, it's already a standard in the Linux kernel, but hopefully it will become a standard for the cloud providers.
So what Facebook's trying to get out of this, and what our initial intent was to bring some standards-based data collection capabilities. That was the initial impetus, to be able to handle any vendor adapter, any technology adapter, and be in a much better position when something does go wrong, to get the data, to know what happened, to get it fixed very quickly. It's a framework, as was mentioned, so the structure allows for a lot of capability, passing of parameters and requests back and forth to the driver, and allows us to have real-time corrective action because there's a mechanism built in to sense what's happened, react to it with some structure, and then in ideal cases recover the machine and put the logs aside for review later. And then the last thing, as a lot of the OCP community is aware, we're very big on this being open sourced, both from a perspective of transparency and visibility as well as the multiple contributors. So we're looking for any of those vendors or individual developers that wish to contribute to please do so. Any questions?
Is it available in the latest Sonic release?
Sonic?
I don't think so because I
It will
don't.
be Debian 9 today.
Yeah, so Debian 9 is based on older kernel than this one, but we're already in discussion with few different companies. There's also our internal switch team in Mellanox have started to backport some of these capabilities into some older kernels. So I'm pretty sure that this will pop on in more than Linux servers only. But you need to understand that currently the infrastructure is ready, but not a lot of action is going on with it because there are only 3 or 4 reporters. So if one wants to use it, it needs to do a design for its own driver and to understand what errors are important and what dumps are important and build free callbacks, which is not a lot of work, in order to support it.
How advanced of a NIC is required for this to actually work? I mean, you've got it on the Mellanox 5th gen, for example. Like, is the 4th gen capable of it, and you just targeted the 5th gen because that's what you're shipping now, or and like with other vendors, like I would assume, for example, the ubiquitous 82599 Niantic Intel probably is not going to get this, right?
The beauty of it is that
I jumped back to the beginning.
Okay. It was in the wrong direction. Is that you can it's a reporter is a software wrapper that wraps everything that you want. You can wrap a software functionality, a firmware functionality, or an hardware functionality. All you need to have is your driver capable of identifying the error. Okay, if you are able to identify the error, then you have the error detection. If you are able to dump related buffers, then you have the dump option, and if you are able to recover, then you have the recover option. But you can, if you don't have, I mean, you can take any capability that you want and build a reporter on it, and like new generation, old generation of NIC, it doesn't matter. If you know how to detect the error, then you are more than welcome to.
A lot of the motivation was the more complex firmware-driven adapters where they have internal checks. But since this is all really driven by the driver itself, it doesn't require that. The question is whether there's enough complexity there to justify the implementation. We've certainly seen a lot of cases where we have to go back in either with a custom instrumented driver, an engineering build, which we hate to do, in order to get the data. And those are the things we're most interested in preventing.
So it's more a question of the complexity and quality of the driver and how many problems you've seen on the NIC.
Well, how many problems we anticipate?
Yeah.
We don't necessarily have seen any. The new technology is always perfect until you try it. But we anticipate a run rate of events that occur on an infrequent basis that cause an inordinate amount of pain, and diminishing that pain is really worthwhile.
I mean, if you have a NIC that in production, you must have a vendor-specific tool, error formats, and error recover tools. Then you just need to wrap it nicely into the software of the kernel, and you can use it. We used it for like TX timeout is very standard in the Linux kernel. I mean, almost every vendor has it because the Linux kernel can detect it by himself, and it doesn't need the hardware to do so. So this was the first reporter. This was the POC that we added. You can take a look. It's relatively very easy. We just replaced the Mellanox only things that we did. We just put them into standard operations. Then we got it almost for free. I didn't have to develop almost anything for that case.
Do the reporters get implemented in the driver, or do they just use the driver?
It's the only thing that is inside the driver.
Inside.
Yeah, you need to register to the Devlink layer. I won't say it's for free, but it's very easy. If you have PCI device, you just give the PCI device, and then you call to Devlink register with that PCI device, and then you need to implement a reporter, and to attach it to your Devlink instance of this PCI device. And from that moment on, we have, like, for the firmware, we have some bits or some events in the firmware that that triggers, that tells the driver that there is an error with the firmware, and all the driver does is just called Devlink error detection method. And from that moment on, Devlink knows that there is an error, and then it approaches the driver, give me the dump so I can save them. Do you want to do a recover? And that's all.
We didn't want to have a whole separate parallel software track of different modules that had to load in and hook. So it's kept mostly in the driver.
Any more questions?
Okay.
Okay. Thank you.